Okay, so we're looking to make a relationship between two things that measure the same thing. So slope is a measure of how steep your line is. It measures the rise, it measures the rise and compares it to the run. Okay, so this line right here has a steepness or a slope of 1/3. Now, we said that if we measure the angle between a line and the horizontal, okay, so it has to be this angle right here, then that also gives us a measure of the steepness. So slope and angle has to be this one here because, of course, if we start talking about this angle over here, it does, in some ways, it's still part of this triangle, and of course it's a right angle triangle. So if I know the pink theta, I could figure out the yellow theta, and then I could talk about the steepness, but this sort of doesn't give me a really direct idea of the steepness of the line. So um, when we say that an angle measures the steepness, we're talking about this angle right here, the angle between the horizontal, okay, here's the horizontal line and the hypotenuse. So I'll just abbreviate that as hypotenuse. So it's this angle here that gives us the steepness. So slope and this angle, theta, both measure steepness. So we're looking for a relationship to move back and forth between them. Okay, so the relationship that connects them, well, actually, let's look at this first. So I'm going to show you a simple one that we can easily get. So this angle right here, right now, looks like it's less than 45 degrees. And actually, it clearly is, because if I draw a 45-degree angle, it would be right in the middle of this 90 degree. So I'm going to draw a 45-degree angle. And if this angle right here was 45 degrees, and then I start drawing my straight up and straight over so that I can see the rise and the run, this would be 90. And since all three angles in a triangle add up to 180, that would mean that this one must also be 45. 45 and 45 is 90, plus 90 is 180. If two angles are the same in a triangle, then this triangle gets a fancy name. It's called an isosceles triangle. This angle will have to be the same, or this side will have to be the same length as this side. So looking here, our run, say 3, is the same as our rise, say 3. So we know that if our angle is 45 degrees, then that corresponds to a slope of rise over run, 3 over 3, 3 out of 3, that's all of them, that's 1. Okay, so 45 degrees corresponds to a slope of 1, a slope of 1 corresponds to 45 degrees. Okay, let's go over here and let's make a general thing. So this rise over run of 1 correspond to 45. What does this rise over run of 1/3 correspond to? What is actually the yellow angle theta? Okay, so here's a little triangle over here. Here's theta. Here's 1, and there's 3. So this triangle here is the same as this triangle here. Over here, we describe the 1 and the 3 as the rise and the run. Over here, because we might be thinking of SOHCAHTOA, just a right angle triangle all on its own. Let's just make that a right angle triangle. SOHCAHTOA. Then, okay, so over here, SOHCAHTOA, this triangle could be labeled where there's the 90, so opposite the 90, let's use a different color, is the hypotenuse, H, and opposite the angle is called O, and adjacent to the angle, or the leftover one, is A. Okay, so these O, A, and H would refer to the SOHCAHTOA here. Let's compare this triangle to this triangle. It looks like the rise is opposite. So this is actually the rise here. And this one here is the run. The adjacent is the run. So if I write rise over run, I actually have opposite over adjacent. And that is equal to the tangent of my angle. So it looks like the relationship between the angle and the slope is that the tan of the angle gives you the slope. So let's check that out. So that means that the tan of 45 degrees should be equal to 1. Okay, the tan of 45 should be equal to 1. So let's check this out on our calculator. So 45 degrees, let's take the tangent of that, 1. Okay, or if we have the slope, so if we're starting on this side and we know the slope, then we could say, hey, if the slope is 1, then what's the angle? Well, in order to solve that, we use the inverse tan. So the inverse tan of 1 should be 45. So here's 1, we're going to take the inverse tangent, and we get our 45 back. Great. So now let's go and figure out what this yellow angle is here. Should I use the small triangle and say O over A is 1/3, or should I use the larger triangle and say O over A is 2/6? We see it doesn't matter, because so long as this angle is the same, so long as this line is going up with the same slope, then the rise over the run, or the opposite over the adjacent, is always going to work out to be the same, whether we're using 2/6, the larger triangle, or 1/3, the smaller triangle. So I just want to use a different color. It's not showing up very well. So the tangent of our angle here, right here, is equal to opposite, or rise, over run, which is 6. So that means that theta equals the inverse tan of 2/6. So bring our calculator up and go 2 divided by 6, 0.3 repeating. We're going to take the inverse tan, 18.4 degrees. So this is equal to 18.4 degrees, which is actually roughly like what it looks like. Okay, it's certainly a little bit less than half of 45. So 18.4 degrees.